So for next example, we have this box sitting on the ground. There is this small bullet coming with some velocity. The mass of the bullet is given. Bullet goes inside the box, stays there, and because of this impact, we want to study the impact. We want to see what happens after the impact when this bullet hits the box and stays inside. So this is outcome one. This is the situation, this is the situation where we have impact, and after the impact, two objects remain together and they move together. Probably, we'll see. So previous example, we looked at outcome two, case one, direct central impact. Now we're looking at outcome one, situation in which two objects stay together. Right? Now, what one thing we also see in this example is that in so many cases, you will see in these problems, in these situations, that you have to use impact, like what you learned today. You have to use that along with energy method. Now, why does that happen? Well, in so many cases, we need to know, remember, impact is about immediately before and immediately after. So we know the velocity before, velocity after, and we want to find velocity after. Now, velocity before, those velocities are not always given directly to you. Sometimes you have to use energy method to find what is the velocity of the objects before impact, immediately before impact. That's the case for this example. We'll see. Let's go over the example. Let me write down the problem or example statement. Right? Example says we have a bullet, right? A bullet with a mass of 3.6 grams is moving horizontally with velocity v, right? And strikes a 5 kilogram block of wood, right? Add to that becoming embedded in it. All right, so it's again possible outcome one. After the impact, the bullet and the block slide 24 millimeters across the floor. We also are given the coefficient of kinetic friction mu k, right, between the floor and the block is 0.4. Right, so we are asked to find, let's say, determine the velocity v. All right, so again, bullet is going, it's 3.6 grams, that's its mass. Going with velocity v, we don't know what this velocity v is, which means that we have the impact between two objects, but we don't know its initial velocity of one of these objects. So the block of wood is just sitting on the ground, so its initial velocity is 0. The mass of that is 5 kilograms. Impact happens, right? The bullet goes inside this block of wood, it stays there, so possible outcome 1. The whole thing, because of this impact, these two together, they move 24 millimeters across the floor. And we are given the coefficient of kinetic friction between the floor and the block, right, mu k. We want to find out what is the velocity v. Right? Let's go step by step. So this is possible outcome 1. We are given m. Let's write the equation for that. Just remember what it was. This is the relationship we have for possible outcome 1, MAVA plus MBVB over MA plus MB. Right? So that's the final velocity, velocity after the impact. I'll call it V prime. This is easier to represent. Let's call mass for the bullet MB and mass for this wooden box uppercase M. So MB, let's write it MBV. Right, that's the velocity for bullet. Mass of bullet, velocity of box is 0, so I didn't write the second part. Again, going back to, let me write the total equation, MAVA MBVB over MA plus MB. MA VA plus MB VB over MA plus MB. Now, MA, let's take bullet as A, so we'll call it MBV, it's velocity V. MB, the box, velocity of the box is 0, so nothing there, divided by MA plus MB, which means MB plus M. All right. So this is what we get. V prime is equal to MB V divided by MB plus M. Right. This is one equation we get. Now, it's just not numbering. So here we don't know what velocity after the impact is. We don't know what is the velocity of this bullet before the impact. So there are two unknowns there. We can't really do anything with that. And we do not also have any other expression or equation that we can use for outcome 1, right, when these two become one object. But we're given more information. We are told that after they get together, they become one object. This whole thing moves 24 millimeters across the floor. Right? So if you want to think about it, we are talking about the relationship between velocity and displacement. Right? So energy method can actually help us. Yeah. Right? So from energy method, we can actually write the expression. We know where we are at the beginning, where we are at the end. This whole motion is 24 millimeters. We can use that to find the velocity. Right? Think about it. We have an impact. So each object has its own velocity. This is box is sitting, wooden box or block is sitting there. Velocity is 0. The bullet is coming with some velocity. They hit. Once they hit, at that moment they become one object, and that's where we start studying this motion using energy method. This whole object starts moving. It goes 24 millimeters to the right in this case, and we know the friction between this tall object and the floor. So if I call that moment 1, let's put it this way, 1. Let me see if I can draw it here. So we have the box, right? The bullet goes in, let's say it's somewhere there. This is 1, and then it moves for 24 millimeters. This would be case 2. This is the bullet there, and then this is the floor. If you want to draw the free body diagram for this, right? If you want to get a sense of what's going on, it's normal. This is friction force. Right? This is N. This is your mass. So when they are attached together, mb plus mg, and this would be your friction force. Fk is mu kn. Right. Let me write one again, case one here, it went under. And this is the motion that goes from here to here. Oh, I just want to use a different color. 24 millimeters. Right. So from, or better to say, using energy method, right, we have T from 1 to 2 is equal to U from 1 to 2. T from 1 to 2, well, initial velocity, we don't know. At the end, it stops. So final velocity is 0. So it becomes 1 over 2 mb plus m v prime squared. Well, final minus initial. Right? 1 over 2 mv 2 squared minus 1 over 2 mv 1 squared. Final velocity is 0. Everything stops. Initial velocity, we don't know. That's the velocity immediately after the impact, is equal to, right, the work done by friction. Right? So we can just go from 0 to 24 millimeters. Right? Fk mu k n dr. This we can write it probably in a more simple term, 1 over 2 mb plus m v prime squared is equal to, well, mu k is given, n is equal to mg, so I'll just write it, well, this is also negative because it's the work done by friction. So minus mu k, remember n, from here we know that n is equal to mb plus mg. Right? So this becomes mb plus m g, and it's, let's convert that into meter. So this is 24 millimeters. This is 24 millimeters. I just converted that to meter. All right. We also know what, well, we know what mu k is, right? This is 0.4, mb is 3.6 grams. So remember to convert that into kilogram. M is 5 kilogram. We know G, same story here, 3.6 grams. M is 5 kilogram. The only unknown here is V prime square. So we can find the velocity V prime. Right? So from there, V prime becomes, I'll give you the value. You can move things around and find the value for V prime. That becomes 0.44 meter per second. So this is V prime. Now we can go back, see what happened. We had this equation 1 there. We had two unknowns, one equation. So from the information given, we realized that we can use energy method to find some information about velocities. We got the velocity, initial velocity, where the block of wood and the bullet became one object and the motion started. Right? That initial velocity is the velocity after the impact for this, the impact that happened before. So we can just use that, go back to what we had for the impact. So from, therefore, that's not how we write therefore. Therefore, from 1, we can find V. Right? That's what we were trying to find. Remember, we're trying to find the velocity of this bullet. It's an experiment. Shoot a bullet, you measure how much the box moves, and you want to find how fast the bullet was coming. So that becomes NB plus M times V prime divided by MB. All of these values you know. Right? This is 3.6 gram. This is 5 kilogram. Remember to convert that to gram. This is gram, and V prime now you know is 0.44. From there you can find the velocity V. That'll become 611.5 meter per second. So that's how fast the bullet was going before it hits the block of wood. Right? So you'll see in other examples that, and in other practice problems I'll give you, that there are so many cases that energy method and impact can be used together to study the velocity of the objects immediately before and immediately after. Well, that's what impact gives us. It gives us a relationship between the velocity immediately before and immediately after. But if the whole system, whole motion is started way earlier, or it's going to continue after, usually you can use energy method to get information. Right? Remember, we're dealing with velocity. Right? Velocities and force and displacement, that's where energy method comes into play. So keep in mind that when you're using this method, when you're studying the impact of objects, not only you use what we just introduced, right? You also have to take into account that you already know about energy methods, and they can be used to study the velocities, depending on what the situation is, what kind of information you need. Now, we talked about possible outcome 1 and possible outcome 2, case 1, direct central impact. There is a second case when the impact is not direct, right? And we'll talk about that later. But up to here, few things I want you to remember is that, remember, velocities are vectors. You have to pay attention to direction. The equations we derived and we wrote, they are based on the directions we assumed. So you have to keep that in mind. Also keep in mind that you have energy method in your toolbox, and we can use that to study velocities.